the main purpose of this card sort activity was to do two things. First of all, to get us used to the distinction between subsets and elements, right? Both at the level of notation, but also at the level of just the concept, right? Because the real agenda that I have for this activity is getting us comfortable with making statements about sets by getting our hands dirty and touching the elements inside of those sets. Because most of the definitions that we work with when we're using sets in mathematics require us to get down into the elements and actually do something with the elements that are inside of them. And the main example we were working with here was our definition of subset, right? So if I have two sets A and B, then A is a subset of B when every element of the set A is also an element of the set B. So to prove this statement, A subset B, which is a statement about sets, we apply the definition and we make a statement about the elements in those sets instead. So keeping elements and sets very clearly distinguished is the key to making sure that we have clarity in these statements. So, and how this activity got to that, right, is I gave you a set that's bizarre in some ways, right? Some of its elements are numbers, the number 2 and the number 5, whereas other elements of this set A are themselves sets somehow, right? The set whose element is 2, the set whose element is 3, and the set whose element has 2 and 3, right? And so I think the first clarifying question that I asked in a lot of your rooms was, well, what are the elements of A? How many elements does A have? And if your eyes are glazing over with the curly braces on this, you might be tempted to think that there are, maybe 3 or 4, or maybe there's 6 elements in the set A, when in fact there's 5 elements, right? The number 2, the number 5, the set 2, the set 3, and the set of 2 and 3, right? Those are the 5 elements. We can list all 5 of them. And that gives us, that's kind of a superpower for us in this problem, because whenever you can list all the elements of a set, everything that we could argue about that set becomes a lot easier because we can just refer back to that list of elements. And so immediately, all of the element questions that were here could be answered just by listing out the elements of A and asking, are the statements that we're making here correct? So 2 is an element of A because it's one of the ones that we listed, right? The set consisting of 2 is also an element of A because it happens to be one of the other ones that we listed, right? These two are not automatically true together, right? They're both true because both the number 2 and also the set 2 are explicitly elements of my set A. Whereas 3 wasn't one of those elements that we listed. The set 3 was, but the number 3 was not. So is 3 an element of A? No, it's not. Where are the rest of my element claims? The set consisting of 5. For the same reason. The set consisting of 5 is not an element of A. The number 5 is an element of A. So that goes on the false pile. Is the empty set one of the elements of A? No. A has 5 elements and we listed all of them and the empty set was not one of them. So the empty set goes on the false pile. And I think that's all the element statements. I sorted 2 of them were true, 3 of them were false. And from there we go on to the subset statements. And these are the ones where we end up needing to plug in this definition, right? The definition that says that something is a subset of A if every one of the elements of my thing can also be found in A, can be found among the elements of A, right? So, for example, let's take this one for starters. The set whose elements are 2 and 5. Is it true that every element of that set is an element of A? It's true, because what are the elements of that set? The number 2, which is an element of A, and the number 5, which is also an element of A. So every element of my first set is also an element of A. So by the definition of subset, the set 2, 5 is a subset of A. And that, again, that is the key skill here in unraveling this activity, and it's really a key skill in working with sets in general, right, is getting at their elements and making an argument about their elements. Is the set whose element is 3 a subset of A? What are the elements of the set on the left-hand side? The elements of this set consist only of a number, namely the number 3. And the number 3 was not one of the elements of A. So this goes on the false pile. But the set consisting of 5, its element is the number 5. And the number 5 is an element of A, so that one goes on the true pile. 2, 3 is not a subset of A. In fact, 2, 3 is actually an element of A, so this one goes on the false pile. Again, because while the number 2 is, in fact, an element of A, Let me zoom out a little bit. The number 2 is an element of A, but the number 3 is not. And so not every element of this set is also an element of A, so 2, 3 is not a subset of A. Similarly, 2, 3, 5 is not a subset. And again, it's the problem that 3 is not an element of the set A. So if 3 is not an element, then any set that contains 3 cannot be a subset of A. And so I wanted to leave this little claim here for last, because I think this is the one that we kind of have the most to say philosophically. Is the empty set a subset of A? To assess that claim, we have to answer whether every element of the empty set is also an element of A. Well, what are the elements of the empty set? The empty set has no elements. And so any statement that I could try to make about the elements of the empty set will result in a falsehood right here at the beginning. So if X is an element of the empty set, then is X an element of my set A? But the proposition X is an element of the empty set is always false. And we know from once upon a time, right, that any implication, any if-then statement, when its hypothesis is false, the implication is declared to be true. So it's like saying, if it's raining, then I have my umbrella. Is that a true statement? Well, I can only tell whether or not that statement is false on a rainy day, right? The only way to falsify that statement is for me to say, oh, it's raining and I don't have my umbrella. Therefore, it's not true that if it's raining, I have my umbrella, right? The only way to falsify an if-then statement is in a situation where the premise is true and the conclusion is false. So when the premise is false, there's no way to falsify this implication, right? And so we can't say that the statement is that the implication, the if-then statement, we can't say that that's false when its hypothesis is false. And so we must declare that it's true when its hypothesis is false. This is what's called a vacuously true statement, which you may or may not have talked about before I joined the class a few weeks ago. But yeah, and so the empty set is a subset of any non-empty set, right? So A here has 5 different elements. And it's true that every element that I could pick out of the empty set will be an element of A, because vacuously, I cannot choose any element out of the empty set. And so any element that I could choose will be an element of A, but I can't pick out any elements at all. So we can't say that it's false. The way to show that this statement is false is to find me an element of the empty set, which is not an element of A. But I can't do that, because I can't find any elements of the empty set at all. So the empty set enjoys this privilege among sets that it is a subset of any non-empty set in the universe, right? Any non-empty set we could write down will have the empty set as one of its subsets. But anytime you're dealing with the empty set, you'll always end up sort of confronting these philosophical questions about vacuous truth and these kinds of things. So always be sort of a little extra careful whenever the empty set shows up in one of these. And remember your definitions, right? Getting from a statement about sets down into a definition that's powered by the elements of those sets, that's the key in what we're doing here. And when in a couple of weeks, maybe next week, no, it would be 2 weeks, when we start writing proofs that involve sets, that passing from the realm of sets down to the realm of elements is the key to being able to write an effective proof regarding sets. So this was just a first taste of that today.